IVR, meaning either the building or the group of doctors or the doctor itself. There is an IVR pool where they can retrieve different kinds of IVRs already made, so they don't have to create new ones. And there is another requirement. This is very specific, which is pound detect. We're going to talk about it later, because for most of us, pound detect is, what is that? I mean, Asterisk does, channel C does detect pound. That's the way it works. So we're going to see that that is a problem for doctors. Text-to-speech, nothing strange there. Reporting and recordings, obviously specific keypads per user group and storeable events. So our toolkit again, Asterisk, MySQL, real-time, AGI, and dead AGI. We do have dead AGIs here. Dictate, and for text-to-speech, we're using AppSwift, using Substore voices, which work pretty good for us. So the solution here has to do with, well, session initiation. There's the ID assignment. There we get all the specific data for that user from the database, and we get the personal data, and then we use it for text-to-speech, welcome Mr. or Dr. or something. Then we have the IVR key, which is very important because with that IVR key, we identify the IVR for that specific user in real time. And we get all the dictation parameters. What are those? Well, that's what I was referring to before, the kind of keypad he has, timeout, max silence, etc. And obviously, we create a dictation unique ID. And the new feature here has to do with pound detect, which we're going to cover. Now, AppDictate is a great application. And even though we tried forcing the actual keypad of AppDictate into our clients, they would say, no, modify it. So there were a set of new features where we're priority set. They wanted to, during the dictation, be able to set that dictation as a priority for the process. They needed standard key mapping, meaning dictate works with only one key. So there are no combinations, and that really narrows the amount of features that you can put into a keypad and makes it very complicated also. And they wanted two different recording modes. They wanted insert mode and they wanted overwrite mode, which are not present in dictate. And we also modified other dictates modes to behave differently, but those are totally new. So priority set is pretty simple. It's basically retrieving the DTMF and sending a flag into that particular recording session field for priority. So there's no real trick there, except, well, we're using MySQL from the C application. Insert mode and override, well, that's a different thing. Basically, what we do is in insert mode, while they're in playback, because they can actually rewind, and well, the rewind time is also configurable, and that's being retrieved from the database at the beginning of the session. And once they get to a certain point, they may hit insert, and what we do is we create an entire new file, and we start recording that new file. And as soon as they hit playback again, then what we do is we copy over to the new file, which would be the third file, the first segment, then we copy the second file segment, and then we copy the remainder. Now, for this, when we're handling audio frames, AppDictate has something very, very nice, very neat, which is a constant frame marker. It has, basically when you're using dictate, and in any given time, you know exactly in which frame of the recording you are. So basically all these coordinates are being given to you for free by dictate, which is very useful, especially if you're trying to do all these things with files. Overwrite, which also doesn't exist in dictate, I guess for a reason, but these people really want to use their phones as recorders. What we do is we calculate the difference between what was recorded to be inserted and the remainder of the original file. And basically, if it's greater than or less than, we do add the difference or not. So it's very simple. We do realize by seeing this that we do have a lot of cleaning to do. And we do have the file system in the middle, and probably some questions will be directed in that direction at the end of the session. The pound detect issue, this is really new. It was absolutely new to us. And at the beginning, I will be blunt with you. We didn't understand what they needed. It was, but you don't want pound. No, I want it, but I wanted to know when they hit pound. But, okay, explain it to me. And when they explained it to us, we really understood what they wanted. These doctors might be in the middle of a corridor, and they might enter their code, but all of a sudden, somebody calls, I don't know, some of those things that they call at ER. So they rush, like the superheroes, and they put their phones in their pocket. They don't want to continue with the recording session, even though the code that they enter is correct. So if that happens, if we do accept that code and we begin the recording, there would be a blank recording that would last the max amount of time allowed by silence. And that would create a lot of problems in terms of, a lot of cleaning to do. So we started thinking of very complicated solutions, and basically they told us, but listen, why not pound? I mean, if they don't hit pound, they die there, that's all. So we thought, oh, okay, let's play with a timeout, let's play with that, let's play with a timer. We started going, and all of a sudden we realized, just got to go into read. We went into read, and it's not a read problem. It's not a problem at all. We actually had to go into channel.c, which is actually the one handling the DTMF. So we created a very basic solution, and we added a channel variable called seed pound, because we were playing around and seed came up. And basically what we do is when the user hits the pound key, which is retrieved by channel.c, we set the variable with the setVar helper from the Asterisk toolkit into the channel. And so there would be a difference now between entering 1, 2, 3, 4, 5 pound and 1, 2, 3, 4, 5 timeout. And the difference would be that if he enters pound, he will in the dial plan we will find seed pound as 1. Otherwise, we'll find seed 1 as 0. So it was a very, very easy to apply fix, but it provided us with a lot of other things we can do now. Because this applies not only to pound, it applies pretty much to whatever you digit. So we didn't want to show a lot of C code because you're already snoring, and we didn't want everybody to start sleeping. But this was very easy to pinpoint. So this is the as reading string fold function in channel C, and what we do very basically is at the very beginning we set that variable, and then what we do is we set it in the channel, and over there is where pound is detected, and we set seed pound to 1. So that's pretty much it. It's pretty straightforward, but sometimes, the thing with the bolt, the bolt is cheap. Sometimes what's really valuable is knowing where to put it, and it took us some time to find out. Maybe it can be useful to you. So, well, that's what I shouldn't use animations. So, recording. I said before that we were using data AGIs on this one. And the reason is because the doctor might end up the recording process properly with a keypad, because this provides the doctor for another loop, and it would send him back to his own IVR to start another recording. But he also might just hang up. So basically what we do is if it's done by the keypad, then the dictation ends, and right after that we run the AGI. And if there's a hang up, basically we run the same process but with a dead AGI. which becomes a very simple diagram. And I cannot believe I made it on time. Woof. You must ask me one question. Yeah, sure. Profitable. No, no, not really. So far, it's been working fine for us. Right now, they're all calling through 4 SIP trunks, so through 4 different SIP providers. Uh, what's the? Oh, right now? Oh no, we're running. Well, it used to be Subtil, now it's Dotty. But no, there's a TVM card involved. Yes, we're running. Okay, I didn't understand the question. He said, "What's the timing source for the conference?" And yes, it's hardware based. Anyway, which is the the sizing. Right now we're running on a dual quad core 2.4 with, I believe it was 16 gigs of RAM, and it's behaving quite well. Uh, yeah, well, we're right now we're having pretty much like we're around like 10 conferences simultaneously, and we're having about between 10 and 12 sometimes in each conference. But remember that this is a it doesn't have a lot of volume. The value here is not the volume. The value here is what we do with the conferences for the firm and how it helps them more accurately account every single dollar and every single minute, and how the process it's been created to allow them to do it easily without handing out papers or filling in forms or anything. That was originally the main purpose of the solution. No, 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 by no means. These are lawyers. This is not, preachers. I mean, they don't have like a thousand people in front. That's why we try and explain what this was about, because usually the conferences never go over that. It's very, very hard to do that. Basically, when that happens, it's because many lawyers are being part of the conference, but a client usually has 4, 5, 6 representative stops. There's no scenario where a single client for a single case would send out 20 callers. Oh no, the same scenarios as Meet Me apply. They can all talk. They can all be muted. That's why the conference owner is so important. No, no, no. It's been mixed. That is per request, but it's an option, and really, really minimal amount of conferences are being recorded. Mm-hmm. They have their own portal for administration purposes, in order to create all the conferences, in order to manage